In this paper, we present Mustard, a multi-user see-through augmented reality display. Mustard works as a see-through display by interacting with polarized and unpolarized light differently. Unpolarized light passing through a linear polarizer gets polarized in one direction. The polarized light will be blocked by another polarizer at 90 degrees to the first polarizer. A liquid crystal panel acts as a light valve and twists the light by 90 degrees. This allows it to pass through the second polarizer. If the first polarizer is absent, then the LC and the second panel allow all unpolarized light to pass through. At the same time, the setup regulates polarized light such that the content displayed on the LC is visible to viewers. The objects are illuminated by unpolarized light from above and are visible all the time. The data LC panel is in front of the objects, and its content becomes visible due to polarized light from behind. As seen in the video, polarized light can be used to display data on the modified data panel LC. If a normal LC panel serves as the polarized light source, we can control which part of the data panel is visible. A random pattern of white dots is shown on the normal LC. If a pixel of the data panel is in line of sight with the white dot, its contents become visible. By changing the dot pattern, the entire view for each individual user is revealed in a short time period. This approach still leads to a small number of conflict pixels that are visible to more than one user at the same time. This conflict can be managed by using conflict functions, which try to minimize the noise for each user. Here you see two users using the system at the same time. Each one sees a different face based on where they are positioned. A head tracking system needs to tell Mustard where the user's eyes are. This allows Mustard to generate the view for that user. This is a block diagram of Mustard. It shows how a physical object placed between the two LC panels will always be visible to all users. At the same time, the rear LC acts as a polarized light source so that the different data is visible to multiple users based on their spatial position. Mustard first computes a whole mask pattern that is displayed on the rear whole mask LC. It then computes the complete views to be shown to each individual user. Using the whole mask and user positions, only the regions visible to each user are collected for the next step. The conflict function resolves the colors for the conflict pixels and generates a single composite view to be shown on the front data panel LC. For more details, please visit our website.